Yeah, thank you very much for having me here. My name is Vanessa. Thank you for the introduction as well. And as Dirk Hofmann told you, I have the solution for all the unstructured data. I'm working at MHP as a senior data scientist, and I'm not working in a cellar in the dark. I'm at the customer side at the very beginning. We're defining the use cases together. So, kind of different approach. And today I want to talk about text analytics. And before I start with use cases, I'd like to give you a brief motivation why it's important, like nearly for every one of you. And afterwards, in the use cases, I'm going to show you two methods which are very handy for these use cases, or kind of. And afterwards, I'm going to show you why it's very challenging in that kind of area for data analytics. The amount of data is exponentially rising, so it doubles every 2 years. However, just 1.50% are used in data analytics. And on top of that, 80% to 90% are unstructured, as Dirk told us before. And University in London anticipates that the global growth in GDP will be 10 to 15 trillion US dollars when you're realizing data efficiency. That means, or trillion, yeah, that's a number with 16 zeros. Imagine that. According to that means that you can realize 8 to 12 trillion with text analytics. So maybe now you see there's a cake, and I think there's a piece of it for every one of us. Before we go and deep dive what's text analytics, as we understand, or if you should understand it, it's the process from unstructured data to data which is machine readable or understandable, that you can build on top of that, like your regular AI applications. The process, as we understand it at MHP, is from the very beginning, from the sources to the usage. If you stop somewhere in between, I have this very cool highlighter. If you stuck somewhere in between, you won't realize any potential. You need to use it. So we will start with the sources. There are a lot of sources for text analytics. You can imagine everywhere where people are interacting in a digital way or writing emails, stuff like that. We're generating text. For example, all the PowerPoint presentations in your company, you can imagine how much data that is and how worth it would be for you if you have a clue what about inside of these PowerPoint presentations. Side information, there are text analytics use cases, how to find or that you can find the right slide for your search, just an info. And all the World Wide Web, as Dirk also mentioned before, the social media, all your customers' inquiries, also some interactive communication with bots, as Professor Hego will show us. They are also leaving all unstructured data, so we have a lot of potential data sources to use. Afterwards, you're collecting them and save them in the storage, and then it goes into the dirty part, and the part which there's the biggest difference between text analytics and the regular classical data mining approach, because in the data mining approach you already have your features, and in text analytics you have first to generate them. There are a lot of count-based models to generate these features, like you're just counting how many times the word hello comes into this email, and then, for example, you have every word, like hello, a column for it, and the number of how many times you have it inside. Due to the shrinking costs of performance power to calculate harder algorithms, you are able to make word embeddings, which are using deep learning algorithms. And in that, you're going to the next phase, like here. You're using AI to build a better word embedding, is called. That you take a word not just by counting it, you take a word by the company by the accompanied words, which it keeps, that you have more idea what it's about. I will come to that later and show you that on a very handy example why it's important. Afterwards, if you are structured then, with which was the goal, you are then training another model like your regular AI models, a neural network to classify, and that's very typical for text analytics use cases, yeah, that you're not, most times you're not answering any business problems by just having a good word embedding, as you mentioned before. On top of that, you need like classification, what kind of problems your customer is talking about, for example. Then, when your model reached a good accuracy, you put it into the model storage and you provide all your business applications with that technology or that intelligence, and afterwards you bring the results of your analysis into the customer interfaces where, as I mentioned before, the potential is realized then. There could be any visualization to further explore your data or a service which you provide in the car or wherever you need it. Yeah, there are a lot of use cases, and I could talk, I think, 3 hours about these use cases. I brought to you 2 of them. One is in the production, and why in the production? At the first glance, I also thought, okay, text data in production, how could that be? But it's a very important part of the production, so that's the reason why I brought this to you. And the other one is more into, or is very customer centric, and but the shareholders or stakeholders who are beneficial from that use cases are like the product development, customer engagement, marketing, sales, and so on. So that's the other one, and I'm going to start with the production one to give you an idea. The customer on this project is a manufacturer in the for agriculture machines, and it's about 1 plant, and they have now a rework rate of approximately 20%, but that's not meeting the goal of the strategy. So the quality engineers are facing the challenge that they have to reduce the rework rate. But the thing is that the information about rework is just written down in a text field, in a free text field, because in production, when there's rework at the assembly line, the workers just writing it down by hand because they don't have time to transform it directly in the system. So the poor assembly line worker at the end has to transform all the handwritten scrappy notes, and that's what they are then trying to search with Excel, with search and find, and then they have to search also for all the misspelled words or abbreviations and so on, you name it. On top of that, there are 700 different assembly groups, so they also have to fill in some structured information, which are a drop-down menu. But you can imagine if you're working under pressure, how happy you were if you have to find in 700 assembly groups the right one. So they're choosing most times others or nothing. And this information also is just written down, so in the text field. The time to repair these defects or the rework takes varies between some minutes. Also, they're doing it on the line, like running behind that, so they don't have to write anything down. But it also can take different or more days if they have to reorder, for example, an assembly part which comes from another plant. So you can imagine agricultural machines are very big, they take a lot of place on the plant, and I think you get an idea of the business case as well. So what was the solution? We were conducting rule-based concepts. That means that we were writing dictionaries, and on top of that, building linguistical rules which are combining these different dictionaries to concepts. They are called concepts in that subject matter. So we were able to detect error parts in the text fields. Is it about the chassis, or is it about the engine or something else? Also, we did the same thing for to detect the error type. For example, is there a leakage or a scratch, or was the part missing, and so on. And also another concept, the third concept of them three, to get a better idea of the error location. For example, was it above or under or between something? You can imagine the big machines and there are big parts. So you had to be more specific to know where the rework was placed. And then we were combining these data after we were annotating it from the text data with the structured information, like how long it took to do the rework and so on. And we were putting everything of that in a dashboard. So now the quality engineers are now able to analyze their data, rework data from different kind of perspectives. For example, they can check how many or what kind of problems do I have with the chassis, or the other way around, they can check on how many parts or on which kind of parts do I have any scratches on it. So you can see that something which was not able before or do it in an adequate way is now possible in like minutes. But maybe you see it's very descriptive. We want to go a little bit further to more intelligence into the process. So the next step is now that we're combining the data we were generating with all the other assembly line data, for example, the sensor data, the cost center data, so who is responsible for this error, and also on top of it, the factory worker data. With that connection of the data, we are now able to be prescriptive and also predictive. So you can get actions or define actions before they already happen. And that's a bit more intelligent than the first step, but that's a thing we have to do. And this is a very good example that just analyzing data, it's not solving the business problem, it's just getting a better base to attack the business problem. The next use case is about, as I mentioned before, very customer-centric, and it's on high level, it's about that there are a lot of data or customers or potential customers or anti-customers, like the customers from other competitors, which are talking, and they're talking to you, and it's getting very competitive in this market, so they have to listen what the customers are talking about, especially on the inquiries which are addressed directly to them. But there are more than 100,000 a year, tendency rising, and they are not just the data which are addressed directly to them, also the external data or customer surveys, as you can imagine. On top of that, they are internationally, so they are working in at least 10 different markets, and you can imagine that there are more than 10 languages and slangs and so on. So it's not possible for them to analyze the data manually, or at least it's not efficiently to do so. Or even if you have any issue, but just in a market or in different markets, and it's 10 times happening in Germany maybe, and 10 times in Great Britain, nobody would talk to each other. But if you have that in a headquarter, you maybe think, okay, I should take a closer look to that. What we did in this project was developing a big customer satisfaction hub, where they are also able to analyze the data from different perspectives, for example, from a technical point of view, also checking what are the customers talking about, different customer touch points, or as well what do they say about our brand values. Do they think that our tradition is broken because of something that happened in the market, for example, like that? And the cost center in this project was in the customer service area, but as I mentioned before, the stakeholders who have benefits of this project are all over the company. And what I brought to you is now the core enabler in this project, which is a knowledge graph, which I want to shortly introduce you to, because I think it's a very valuable method to attack problems like this. Graphs are, or knowledge graphs are networks, and they are existing of objects, here shown as bubbles, and they can have have a type, for example, the Tesla Model S or a customer ID. And they also can have properties, for example, this customer ID 123 could have a name and an address and so on, or an A rating, for example. And there are a lot of dots. Knowledge graphs aren't static, so they are evolving from time to time. So every data you push in it, it's getting bigger and bigger. They are getting new relations, because they have relations to each other, and that's the point. If you have relational databases, you don't have a good visualization or a good possibility to attack these relations. And in text data, the importance lies the most times in the relations in between them. So a relation could be that a heat seating, for example, is part of the Tesla Model S, or this customer is owning, for example, a car like the Tesla Model S, and maybe because it's a Tesla Model S P100D, he's A-rated, and he complains about the seat heating. Now the company knows which customers are complaining, for example, about the seat heating. And imagine that there's this quality guy coming to you and asking for all the A-rated customers who has bought the car in March and have a criminal record, living in Germany, complained about the seat heating in the last 2 weeks. Before it was like, what the hell, get out. But now, with the knowledge graph, it wouldn't be a problem anymore for you to do this. So, and that's the method which is, gives us the possibility to enter the knowledge graph from any node you want to check, like the technical stuff, the customer touch points, the customer ratings, or go from the source that you want to see, just the stuff which comes from the social media part or whatever. So that's a very nice tool. And also Gartner tells us that knowledge graphs are going to be a method to be in, I think it was last year, in 4 to 9 years, it should be on the top of the hype cycle. And as well, there was a paper this year, I think in March, it was from researchers from Google Brain and MIT, which are doing great stuff in the text analytics things. And they brought a position paper in March, which says us that we have to concentrate on these models or on presentation of data which has these relations in it, because you're not able to get a higher maturity level in AI if you don't have the relationship between different things, because that's the reason why we can transfer our knowledge to other things, because we can intercorrelate them. So you're benefiting when you're using knowledge graphs, that you have a better insight of what's in your textual data, and on top of it you have a good base to learn, create AI models on top of it. So as I mentioned before, or as I promised, I want to give you a short and very handy example why it's important to know a word by the other words, accompanying them, or joining them, or have it in context. When you see Cayenne, what's the first impression? What are you thinking about?
Cayenne diesel.
You're thinking about the car, right? True. Huh? Yeah, you have seen the slides before. You're not allowed to answer.
Pepper.
Right. There's also pepper. And?
American natives.
Really? Okay, so I have to have a new category. Category. What?
Female name?
No, It's a location, but don't ask me. It's somewhere at the sea. Yeah. It's in the French Guiana or something like that. Yeah, but so now you have no clue what this Cayenne is about. When you check the context, I think it's getting clear that we're talking in that case about the car. But also there are cases which you have the context like this. I shot an elephant in my pajamas, which is a very prominent, famous example for this problem in text analytics, because now you have to choose if the shot, or if I was wearing pajamas when I shot the elephant, or was the elephant wearing the pajamas. So if you are parsing that, like you're trying to detect the logic in the sentence, you have to choose now, is the in pajamas according to the elephant, like that, or is it according to the short phrase? So could you know which one is the right one? Okay, I'm going to leave you with that so far. So the 3 takeaways, I don't have 10, I just got 3 maybe. So there's a lot of text data, and according to that there are a lot of use cases, because everywhere where text is, I think there's also use cases for that. You have to validate if the effort is in balance with the benefits you will earn to that, and I think Dirk also shows you how you can validate which one is the low-hanging fruit or not. You should do that. And text data, as you have seen, is very fuzzy, but there are solutions, or often, in my experience, it is that it's just not, there's not one right algorithm for one problem. It always depends, and most times of it's a combination of different methods and algorithms, which leads you to the necessary quality level. And also, there's a solution for this problem, and that's my advice: just take more context to it. So thank you very much.
So before we make a break because of the hotness in the room, what questions do you guys have to Vanessa? Why do you think I have one? Why not just solving the unstructured data problem with giving more structure? Like the assembly line guys could just have different fields to put in the right information, and then you would have more structure. Is it not much easier sometimes?
You mean in the production case? Yeah, that's a good question. We were asking that also at the first time. Yeah, also me as a data analyst with a text analytics focus. They have these the possibilities to fill the structured information. As I mentioned before, they have a drop-down list, but they don't have time, so they're just taking sticky notes, and that's it. And then at the end, the last assembly line worker don't want to fill out all the structured fields, drop-down searching between 700 possibilities for the right one. So they're just writing it down. It's much faster. And it's the same problem also in call center agencies. We have the same problem that the structured data is not that good. Yeah, so that's the reason.
In accordance to your question, does this company thinking about to complete the recognition database with a voice recognition? Because if the worker has no much time or no many time, so he can put a button and speech to the system and say by words for him for his problem could be the reason or the situation or the problem, because that's also naturally for future, but in future then you can detect via voice recognition perhaps more significant and detailed allocation of the problem.
Yeah, that's a good opportunity to make the process more easy for the assembly line worker. But afterwards, you're transcribing the speech or the voice as well to text, and then you're using the same methods behind that. But it could be an option for the assembly line workers, yeah.
There was one question, Ray?
Yes, I have a question. Sorry, can you hear me?
Yeah.
Yeah, okay. I was just wondering how much of the tool has the GDPR, so the General Data Protection Regulation, affected all of this process?
So I did not get the whole question. How much?
So the General Data Protection Regulation, whereby you can't really use data without people's consent and so on.
DSGVO. What's the problem?
So
how much?
if you're your company and you're analyzing data from people have commented about your product and so on, has that, so I'm thinking of the second use case where you take that data, has that affected this process or?
Yeah, there are a lot of regularities which have to be proven by the lawyers in the company, and we're just doing things which are legal. So it was taking a long time, and technically there are a lot of more things possible to do. But there are.
I was just wondering, sorry, I don't mean that at all.
Okay, sorry.
I was just wondering, has that made it more complex in order to sort out all the data?
Yeah, because we have to implement also some processes which are deleting documents after analyzing them and stuff like that, and that makes it much more complicated, especially when you have like a complete recrawl or importing your documents. You have to be aware that which kind of data you already have inside your database or not, or should not there anymore, and stuff like that. So yeah, a lot of application management complexity. Yeah.
Thank you.
Yeah, one more question regarding the knowledge graphs. Maybe I missed it, but did you explain like how you build those graphs, or like how do you like put those information into relations?
Yeah, that's a very nice question because we build algorithms which are doing like this, the semantic parsing, because there is a logic behind that you can say maybe, for example, the first noun phrase in the parsed sentence is the first object, like subject, predicate, object. But as you see here, it's getting very difficult, especially when you're thinking about customers who are writing to a company. They're emotionally, so they have very long sentences, and sometimes it's even hard for us humans to define which one is now the subject, predicate, object. So it's kind of a mix doing it automatically with this algorithm, and also building taxonomies and hierarchies and dictionaries, and so sticking it out like partly automatically. Yeah, but it's a very difficult process to do so. Yeah.
Do you also like consider, for example, like emojis and stuff, or emoticons in email?
Yeah,
like sometimes if they like use irony and stuff.
Yeah, we have a logic in there for the social media data. I think you have to use their special annotators, especially for Twitter and stuff like that, because you have there a completely different way to communicate. Also, they are using GIFs a lot of times, or the memes, where a lot of information is inside of the memes. So we are using different APIs to solve that problem. Yeah. So that's a very important point, because text data really differs a lot. It's a difference if I'm analyzing, for example, newspapers, or it's completely different when analyzing newspapers from Great Britain versus North America. And also in Germany, there's a different, and then you're differently communicating in Twitter or in Facebook. That's a difference as well. And also when you're writing a letter to your company where you want to have some goodwill or whatever, you're also writing in a different style. So that's the reason why you have to build your models every time for specifically these kind of data you want to analyze. Yeah.
Thanks so much. I'll ask you.